Today we're going to see this constitutive laws of basic elements. On the screen you have a set of 9 elements that we use in doing modeling and simulation. With these 9 elements we could model just about anything under the sun, and it is a way to generalize the elements that we have in different energy domains. And with that set of elements, we could generate models. You have 2 sources here. You have 2 connections, and you have 5 elements. So today we're going to go through the relationships of each one of them and see how each one of them is represented also in a bond graph form, and how each one is represented in the block diagram form. So let's begin. In here, we're gonna go in order as they have appeared in there. So I am going to write down in here you would say source elements. Okay, let's just put an example in here. The first element that you see in there is SE. What does it mean? This element source, and this means element means source effort. Okay, and so let's go one by one. Let's give some examples of this. A voltage source, like for example the wall, 110 volts, that's a voltage source. Applied force, okay, that is a mechanical system, that is a source of effort. Then you have like a pressure source, that's also an effort source. A moment, a torque, that is also an effort source. Then you have in the electrical domain, as I say, you have the voltage source. So what we're going to do is we use the symbol SE for this, and in here we say, like in here, let me put the SE in here with this color. Okay, so here, if we put SE as a symbol in here, the source is going to give power from the source to the system. So if this is the source, this is the system here. Okay, and we are going to use this crossbar like here to indicate that what goes on from the source to the system is your effort variable, the E variable, the effort variable. And the other way, this is your flow variable. Okay, variable F. So in here, this is your bond graph model. If we represent this in a block diagram form, you will represent it like this as a source of effort, and then in here you have, if this pushes the variable E and this receives the variable flow. See? So you have in here your bond graph model on the left hand side. You have the block diagram in the right hand side. But this is in general, and the what it specifies is, the constitutive law is basically, you could say the source of effort equals to some value, let's call it value here, of an E variable. That's what you have. Okay, so I think it would be helpful now to maybe let's do a little graphing here and do the equations of each one. So an electrical one for a voltage source, normally we put it like this. Yeah, we do a little drawing here with plus and minus like this. Yeah. For a mechanical system, you have it like this, and this is an applied force like that. If you have a hydraulic system, like for example, you have a pressure source, let's say an accumulator that has pressure in here from a source, or a pump maybe. If you have a pressure source in here, and then if you, for a rotational system, if you have a torque like this, this is your effort source. So you can see you have the bond graph model, you have the block diagram model, you have 4 examples of the sources over here. And like for example in here, you will say a source of effort. The way we name things in here, like for example, let me just put a label in here. If we have it like this and this has a number, let's say 5. So this is the bond number. The way we name this thing is like in the constitutive law is SE5 equals to maybe whatever it is in voltage, 10 volts, yeah? Or we put like here SE5, if it is a force, you would say 10 newtons. Or if it is this kind of a hydraulic one, SE5. So we put the element, then we put a number next to it. So SE5 is going to be what, 10 kilograms per meter square, like that. And if it is in a torque like that, SE5 is equal to 10, I think it's newtons meter is the way in the units. So this symbol that you see here is a general term for any one of these. But if depending on what you're doing, they would acquire different units. So as you can see, this is your, just put some labels to make sure in here you have, this is your bond graph model. Where do we put the label here? I would like to put it with a different color so that we can distinguish them. So this is your bond graph in here. It's called like this, bond graph. You have in here your block diagram. You have in here this is the physical element. You know, maybe we'll put it on the side over here. We're going to call it physical system. Okay. And then on the bottom, this is what I would call it your constitutive relations. I would like to do this for every single one of these elements. And so far, we have been able to do it for just one of them. Where is it going? I need to go over here, and just this element is the one that we have just done. Just that one. Yeah. I would like to take this one, take all this, and do the same thing. This way we'll cover every element that we are going to use in generating models. So what I would like to do is use the space that we have in here. Maybe I'll put a line in here, a nice one in here, and separate that from the other element. We need to do the same thing for other source elements. So in here we're gonna have to go and put like that. So in this, what about we do the same thing, and we're gonna do SF, which stands for source flow, like this, yeah. And then in here we're going to we're gonna keep the same order that I had. In instead of a voltage source, this is going to be a current source. Okay. Then instead of for a mechanical system, this would be a velocity source. For a hydraulic system, this would be a volume flow source. And for a rotational system, this would be an angular velocity source. So I want to help you recognize the elements and also the symbols that apply to each one of them as they apply, as we see in the different energy domains, and we see in the different ways that we represent this. If we look at the way we represent the system, here we'll say we use the same colors so that they would be uniform in here. In here you're going to say this is the source of flow like this, and the way you represent it in the bond graph notation is like this. So you see this is the source. I'm going to put source flow, and then obviously what comes out of this source is the flow variable, the F variable, the flow. See, and then on over here is the E variable, the effort variable. See, this is the way we represent the source flow. So it remains to be seen what is the block diagram of this and what is the constitutive relationship. So I think just to make it a little bit more interesting here, I'm just going to put a line in here, and I am going to put another line on the other side over here. Yeah, there we go. So this is your bond graph model here. This is but the other one is we need a block diagram. So let's just write it down to be consistent. So this is my bond graph. And in here is going to be my block diagram. And on the this is going to be your constitutive law, or the value. You know, this is going to be like an SF in this case. Let's just draw this. What you have in here is here, if you have this kind of variable, a source of flow, the flow variable is the one that comes out, and this is the one that goes out of the system, and what goes into is the variable E, and you write it like the source of flow like this, and then you put the value of the F variable. Yeah, so being consistent with what we were doing up here, I would like to do it in the 4 energy domains that are represented over there. And here, if you have a current source, it's usually represented like this. Yeah, where what comes out of here is the current I. So this is saying, I don't care what the voltage is, the current needs to be this. Like this other one up here saying, I don't care what the current is, the voltage has to be this V. So this is the electrical domain log physical system. For this, in the mechanical domain, if you have a source of effort, like in this case is saying I specify the velocity of this. So if you specify the velocity of the mass, usually the velocity of the center of mass, so Perhaps I think to make let's make the drawing a little nicer here. And I would put it like this, see? The velocity of this is specified. If you have it on this, in the source of the uh, hydraulic system, maybe this is an easy one, representing it like this, where the variable f is the one representing in here. So in this case, in amps, this other one in velocity units, meters per second, this one's in the volume flow rate is going to be in meters cubic per second, yeah? So, and on this one, if you have a torsional system like this, what you specify here instead of the torque is the angular velocity. So, and you have the constitutive relationship, you're going to say, if this, for example, is an SF9, like that, yeah? What you're doing is you're going to say that SF9 equals to 10, like in this case, amps. Or if you SF9, if it's a mechanical system, it could mean in 10 meters per second like this. And if you're on a hydraulic system, SF9 would be 10 meters cubic per second. And on this one, SF9 would be in the units of um, radians per second. Yeah. So that covers both of those elements, the SF and the SE element. So I think this is the other one that we have just done. What I would like to do next is take on each one of these elements and do it the same way as I am doing it right now, and would leave the two junctions to the end, because these are used to connect the other elements. So it makes sense that we would be able to do other elements, all the elements first, and then we'll do the connections. So we'll take a break in here to continue, but just to reiterate, we have the source of effort, the way we represented it in here, in the different energy domains. This is the bond graph model, this is the block diagram model, and then if we represent it exactly with the bond number, the value that we assign would be in different units in different systems. Same thing is in here. When you have the source of flow, this is the bond graph model, this is your block diagram, and this would be the way the equation is written. Then in here you have the electrical domain, you have the mechanical domain, then you have the hydraulic domain, and then you have the rotational domain. So depending on when you put it like this, the notation, to make it easier in here, you could say that value of 10, you could put like this, see, with two little dots in here. It means that's the value of this. This is the way we understand this. it produces the flow from the system and receives the effort. Okay, so we'll we'll take a we'll break it down so and start a different video with the other elements.